John, we've heard what industry leaders are saying. And if we believe them to be true, and I think there's a lot to be said about what they're saying, there's going to be thousands, millions, perhaps more agents in every enterprise. That is an ecosystem. And that is the fundamental concept that I think we need to rally around if we want to actually realize the value from the agent ecosystem. That introduces new challenges. The question is not whether an agent can do something, but whether enterprises can actually manage what they're doing at scale. And we believe that the agent ecosystem is actually the missing agent operating system that provides the fabric, the registry, the control tower, semantics, orchestration, and reliability to run agents at scale. So that's what we're going to talk about today. My name is Eric Broda out of Toronto, Canada.
And I'm John Miller from San Francisco.
And the topic of today's podcast is the agent ecosystem, the missing agent operating system. So, John, where should we start?
Well, that's a good question. I know that there's a lot of material that's been created already to talk about some of the foundational capabilities of the agent ecosystem. So what I'd like to suggest is perhaps in Act 1, we do a scan of what we say are the key components of that ecosystem. In Act 2, let's dive into the one that we've been talking about as sort of the hottest off the press, this idea of the semantic layer. And then in the Act 3, we'll bring it all back together.
I'll start with each of there's 6 items. So I'll go through each.
Okay.
I'll save the semantics for last. So the agent ecosystem, or the agent ecosystem operating system, we see 6 distinct layers or 6 distinct major components. There's obviously the fabric. It is the communication backbone, provides naming services, some level of transport protocol, security, identity, encryption, authorization, authentication, etc. And that's probably the simplest and easiest to understand.
I think we're going to want to keep people following this list of 6 things. And I think it'll be useful to just go drain the list of the 6 topics, and then we get into defining them. Does that feel right to you?
Yeah. Number 1 is fabric. Number 2 is the registry in the marketplace. Number 3 is the control tower. Number 4 is orchestration. Number 5 is reliability mechanisms. Number 6, arguably the most important one where we're going to spend most of our time, I think, John, is the semantic layer. So why don't I go through, kind of bring these things to life, and then we can spend some more of our time on the semantic layer. So
Yes.
the first one I mentioned is the fabric, the ecosystem fabric. This is kind of the first part of the agent operating system. It provides a bunch of services, naming, protocol normalization, transport, provides security, authentication, authorization, encryption, for example. And it obviously supports some basic higher level protocols, HTTP, gRPC, event streaming, etc.
Okay, so I love that you're calling it a fabric. So why did you choose the word fabric per se? Because in IT, we've used the term fabric. We usually don't mean a quilt or the stitching of a sheet. We're usually talking about something. Are we talking about the communication fabric and all of the capabilities around that?
Yeah, I'm going to try and draw an analogy, and I'm pretty sure it's going to break down a little bit. But when I look at the ecosystem, it's almost like there's this transparent layer of stuff over all of the agents in our case that bind them all together, allow them to interact, allow them to collaborate. So it's almost like if you have the quilt that you mentioned, these are the designs that sit on top of the quilt that bring the quilt to life, if you will. So that's why I call it a fabric.
Okay, so I'm going to use this quilt analogy until it breaks down, but I like it because I think that's the first layer. Let's talk the first component. What's the second?
Sure. The second component is the registry and the marketplace. And these are they're actually very related. So the registry is the mechanism by which agents can find other agents. And the marketplace sits on top of the registry, perhaps obviously, but it is the way that people can find agents and figure out which agents they actually want to engage with. So in order to do that, the registry, and again, the marketplace that sits on top of it offers a few services, discovery services, like the DNS for the internet. There's some directory services. It offers some semblance of contracts, or when I actually look for information about an agent, there are some common metadata associated with each of those. If I use A to A, the Google's agent to agent protocol, you have agent cards or agent skills. It also standardizes and clarifies metadata broadly across the ecosystem. And obviously that's going to support things like governance. And then you have the concept of the agent store, kind of like the app store, if you will, for iPhones, but this would be the agent store for the agent ecosystem in an enterprise.
So if I'm following along, I've heard you use a new analogy for the registry and the marketplace or the store. So when you talk about a registry for agents, I immediately thought of the DMV, the vehicle registry, not because they're great and efficient, but necessarily because it's a centralized body where we all trust that the state will govern the issuance of licenses for vehicles or registering vehicles and registering drivers. So I think of a registry kind of like that. It's a governed place where we can trust the information that's registered there. And there's a tie between the things that exist in the registry and things that you can buy in a store, which is the marketplace. So I'm with you.
Yeah, absolutely. It gives a few more things just to build on the app store concept. It does more than just allow people to find agents that they want to engage in, but it's the if done properly, it's the mechanism for distribution of agents. It's the mechanism for monetization of agents. It's the mechanism, just like the app store, certification of apps to make sure they're safe and trusted, if you will. So it does a whole bunch of things. But John, let me move on to the next one. I believe number three was the control tower. So the control tower, just like when you think about airplanes and the like, what you have is some central body that has the instrumentations and the tools to make sure that, for example, airplanes don't crash into each other. Same thing here. We want to be able to have a control tower for the agent ecosystem so we can actually watch what agents are doing. So observability is is one of the capabilities it provides. Traceability and being able to link agent conversations from one to another, especially conversations that may be very long lasting. And when we have some challenges and we want to understand why an agent did what it did, it provides the visibility to explainability to understand an agent's task plan and what actually happened in detail. And obviously, it provides the capability to, loosely speaking, call it operability, the ability to connect into an enterprise's operations console, view alerts, and as necessary, do problem diagnosis and intervention to the agents.
Okay, so item number three, the control tower, this analogy of an airport where you want transparency or visibility to all of the operating agents or airplanes, and in this case, where you can see and where it's transparent and observable. And, I can think of extending that analogy, but with this concept of a flight data recorder. Where does that fit into the agent? Is that part of the control tower or is that something else?
Well, I think it is managed through the fabric. So if you're using immutable logs, maybe through tools like Jetstream, all of a sudden what ends up happening is you have the visibility to the lower level component. You have the raw data to understand what's going on. The control tower provides that visibility. So like every airline or airplane rather has that black box which is continuously recording what that airplane is actually doing. It's the control tower that watches where all the airplanes are going, and obviously if there's a mishap, hopefully it doesn't happen very often, but when there's a mishap, there's that black box, or in our case the immutable log of activities to understand what actually is going on.
Okay, great. So we've got a control tower, a flight data recorder. What's component number four?
Yeah, so if we're going to have hundreds or thousands of agents in this ecosystem, how do we actually orchestrate or choreograph what they're actually doing? Now, the interesting thing about this is there's no central orchestrator per se, but agents on their own can create task plans. And then they can, based on those task plans, execute those task plans, which may mean delegating to other agents or, consuming other tools. But there's a bunch of different delegation patterns: fan in, fan out. Task plans may be DAGs or directed as acyclical graphs. So there's a whole bunch of different ways that this can actually be implemented. And then obviously once you have the agents collaborating, there's things like workload management, load balancing, some of which you can leverage from some of the hyperscalers, for example. But nevertheless, the concept of workload management fits under orchestration also.
Okay, so if I'm following this airport analogy, I'm thinking that this orchestration layer, this coordination layer, is something that's done to make sure that planes don't run into each other, that they can all land safely, they can take off safely. This coordination of fleets of agents and fleets of fleets, that's what you're talking about in layer 4.
Absolutely.
Oh, Eric, tell me about component number 5.
Sure. The component number 5 is reliability mechanisms, largely offered by the hyperscalers, but it's worth mentioning because any ecosystem, prize grade ecosystem, has to consider these things. And there's some design choices, obviously, you need to make. There's reliability patterns. How do I guarantee idempotency, deduplication, transactionality as necessary? There's resilience patterns, which may cover things like disaster recovery, multi-site. Again, these are things you typically can leverage from the hyperscalers. But then when you start to get into agent mechanics, you need to think about how do I restart and recover an agent when it breaks or when it needs further information, and once you get that information, have the agent restart. So these are reliability mechanisms that allow the ecosystem to function well and in a predictable and repeatable fashion.
Okay, that makes sense to me. This idea that we want reliability engineering built into our agent ecosystem or agent operating system makes a lot of sense. That's why flights are so safe, because there's reliability built into everything that's done to make airlines and airplanes and other flying vehicles to be safe and reliable in the air. Makes sense to me. Now, number 6, the final component.
Yeah, so this is I would argue, and I think we both agree on this. This is probably the single most important part of the agent ecosystem, and it is probably the least represented part of the agent ecosystem. Now that I've teased you, what is it? It is semantics. It's the semantic layer for the agent ecosystem. It is the ability to have shared meaning across concepts that the agents are talking about. And the analogy, by the way, is very similar to when you think of an agent as a person. People, in order to communicate, need to have shared meaning. We have to agree on the facts. We have to understand when we're talking about a particular concept, an airplane, that we all understand what an airplane actually is. So there's shared meaning and common representations, things like a common vocabulary, an ontology, or taxonomy, for example. And then the reason why this is so crucial is we've heard this concept of context engineering. And if I were to make it really, really simple, it's a complex topic, but ultimately an agent built on top of an LLM has a very finite window of information, a space where you can put information that it uses to actually address its requests. If you put the wrong information in that context window, then you get things that are popularly called hallucinations. So in order to avoid that problem, or loosely speaking, inaccuracies, you want to get the right information inside that tiny window. Well, the right information is semantically aligned to what the request semantics actually are. And if you have shared meaning between the stuff in the context window and the request and common representations of concepts, then what you can do is you can actually fill that context window with the right information. Without common semantics, common representation, shared meaning, filling in that context window is hit and miss. And your agents and your LMs are never going to actually achieve the objective that you have. Now, the last one I would say is we've talked about shared meaning, common representation, etc. But the other thing is as we all know, things change. Definitions drift, perhaps on purpose, perhaps not on purpose, perhaps unintentionally. But nevertheless, we want to be able to manage the metadata evolution so that what we said maybe a week ago, a month ago, or a year ago, conceptually can be brought back to the request as it may be requested today. So the ability to manage the evolution of metadata, again, the shared meaning evolution, the evolution of the common representations of concepts, these are all pieces of the puzzle that are crucial.
Okay. Now, as a data person, It sounds like you're talking about the holy grail of a single meaning. So I think that's why it's worth exploring this topic in Act 2 in some detail. So let's jump into Act 2, where we're going to start by unpacking and decoupling some of these ideas and thinking about them and decomposing them, probably more than decoupling. But you said something that we have said in data since I learned that data warehousing was a thing that was invented by Bill Inman. Okay, so back in the 80s, there was this concept of corporate memory. What if we could remember everything the corporation did? And in some facets, we said that the data warehouse was that. So this concept of a corporate memory that records what happened at a point in time, we always knew that that would never work unless we had a common language to describe all of the things. Now, as many of our colleagues know, creating a common language to describe all of the things is a non-trivial problem. And it's something that we've seen many iterations of. You could even go back to the Tower of Babel, but where there is a confluence of languages being used, how do we agree on one language to define everything? Tell me how what you're thinking when you say that, because I want to give you a chance to link this back to data governance, or I don't mind doing that myself, but tell me how you're thinking about it, because we are talking about the holy grail, the common standard language, if you will.
Yeah, so there's a few things I want to kind of highlight. One is let's talk about what happens when you don't have these things.
Right.
There's two problems, loosely speaking, that we see. One is the broken telephone, where it's typically represented as a kids game where you have 6 or 7 kids in a
Yep.
line, and once somebody says, "We're going to talk about this" to the first person, and then that person tells the next one, and the next one, the next one. By the time they all get to the last person, the topic is completely different. And you're always wondering how we got from some clarity around A and we ended up with something that looks like B.
Yep.
That happens all the time. For example, in my career, when we've tried to do in the old days requirements documentation, where we would try and translate I would listen to what a business person would say. I would write it down. Somebody else would read that and translate it into an engineering document maybe. And then somebody would read that and translate it into an infrastructure document. But ultimately, at the end of the day, there's a lack of continuity in the thought process, in the concepts that were embedded in that very first discussion and the translation of those. And that's a very fundamental problem. And I would argue that is probably why there's a lot of inordinate expense and even technical debt in systems development today. Now, the second, go ahead, John. You
Well,
got it.
yeah, yeah. And so I think the spirit of Act Two is conversational. And so I'm not taking us in a specific direction, but rather asking some of the hard questions that I've asked myself and tried to solve in my career in data. And so I love that you're pointing out the first area where, I think the example's called broken telephone, where one child says bees, the other child hears knees, the next child hears sneeze, whatever. It's a great example of losing the meaning as you translate between the speakers, right? And so I think that that direct analogy is exactly right in this first example where you're talking about business requirements. What is a business requirement? Well, when you ask somebody in a large organization, they might say, "What do you mean business requirement?" It's our business, right? This is how we want to run our business. Now, technical people call them business requirements, but business people just call them requirements, uh, and so on. And so there's even in the discussion of what is a requirement, is it's not or has some chance for misunderstanding. But I do like that you point out that if we could solve the common meaning problem, then when we take an idea and we try to translate it into a solution, that we need to have a common language between the design process and the development or coding process. So I think that's one
Yeah.
aspect of the semantic layer, but Might not have been where you were going.
No, I think you hit the nail on the head. That this
Okay.
I want to touch on the second problem, which
Right.
is there's I don't know if it's a proverb or a story from long, long ago about blind men and an elephant. And there's
That's right.
six blind men touching different parts of an elephant, and they're trying to say what they think it is. So the person that touches the leg thinks it's a tree trunk. The person that touches the tail thinks it's a snake, and you can see where this is going. Every one of the blind men have a different perspective on what this single concept of an elephant actually is, and there's a reason for that is that they all have small pieces of the picture. So if you had common representation, full representation, and visible representation of the common concepts, then you would be able to avoid that problem. If you don't, I'll give you the simple example that I see all the time, mostly when I get observe or get involved in master data management. The prototypical example that I see is around customer, which intuitively is a really, really simple concept. But underneath the covers, there's incredible levels of detail and complexity. Simple example, this is just the simplest one, that when it comes to attributes for John Miller in the US, for a US bank would have, these attributes. In Europe, if you had a European account, you would probably be subject to different rules and regulations. And some of those attributes would be different, and some of those may be the same, but not visible. The customer, John Miller, the customer in Europe, is different than John Miller, the customer in United States. Even though conceptually John is John, you are represented differently, and the ability to harmonize those and recognize not only the similarities, but the differences between the two is, I don't know if it's a lost art. I don't know if we actually have that skill to call it an art, but it's very, very difficult to do. And that's what we try and address with a common semantic layer.
Yeah. I think the example you give of multiple attributes defining a customer, depending on the jurisdiction, the UK, Northern
Uh,
Europe versus the US or Canada. I think that's one example of it. I think the other example is with the blind man parable is this idea that somebody that's doing marketing just cares about that transition between a marketing qualified lead and a sales qualified lead. Like depending on the function you are in the business, you might think of customers as prospects or, you know, MQLs versus sales qualified leads versus, with this similar dichotomy is a prospect versus a customer. So there's lots of examples where, this blind man issue sort of reveals itself, but we don't have great solutions for that. How are you thinking about solving for that? Because I would argue that that is something the data governance organization or the enterprise data team has been trying to do since the dawn of computing.
sure. And you know what? I having been there a little bit, not quite as deep in the details as you were. It's a difficult problem to solve, or it was a more difficult problem to solve than it is today. And the reason, my humble opinion, is that we have brand new tools, large language models, agents that can help us make sense of the vast semantics that exist within an enterprise. They can actually understand and pull out the representations from vast amounts of structured information, unstructured information, voice, video, images. So for the first time, we actually have an opportunity is to actually to look at the vast amount of information that's out there, whether it's standard operating procedures, stuff in a database, stuff in an image, a content management system. We can actually start to make sense of that at scale. Now, we need to put some structure to that in order to manage something that is at scale, but actually make it useful at scale. And that's where the shared meaning and common representation, interesting enough, the tools can actually do that also. Not perfectly, but they're the equivalent of a power tool compared to the old days where we had hammers and nails. And that's where I think there's a huge opportunity. So a simple example, perhaps, is tacit knowledge, that being know-how, loosely speaking, is know-how. It's the stuff in everybody's head. It's the stuff that is notoriously difficult to extract. Some of it we get into these business requirements we talked about earlier. But here's the thing is The simple process that we go through every time we try and build a system is we talk to the experts, we write it down, and then we try and do the broken telephone thing perhaps and implement it. The interesting thing about this now, we have some real world experience with this, John, as you know, is we can actually do things like interviews and capture that tacit knowledge and put it into a share, a repository, get some common or shared meanings, get some common representation concepts, and actually make that queryable. Now, that takes work, but we actually have for the first time the tools that I believe we can actually do that at scale. That is a fundamental opportunity that I don't think everybody is taking advantage of, but that today, in my opinion, is low hanging fruit that if you're not thinking about how to actually capture not just tacit information, but unstructured information using these newer generation of AI tools, then you're missing a huge opportunity.
How do we store that knowledge in your mind? And this is a trick question. How do we store all of
Yeah.
that knowledge you're talking about?
Well,
Because I think
yeah,
that's the
there's the,
fun part of the discussion, right? Where there are
yeah,
a lot of systems that have been developed to try to capture knowledge over time.
yeah.
This is
I think,
probably something we lightly touch on and then explore in a future episode because there's a lot of important buzzwords, but also important concepts that we should be sharing before we get into nailing
yeah.
all of the semantic layer meaning.
Yeah, well, let's start with and by the way, I know you have some pretty strong thoughts on this one, opinions on this one, but let's start with the simplest that we could do, and I'll use some old world technology or old world meaning. We should have a glossary or a dictionary. That's the
Sure.
simplest thing. So,
Listen,
but
a
yeah, we
dictionary, let's talk about a dictionary for a minute, man. What I love about a dictionary is this is how human beings are trying to do it, right? We're not perfect. We disagree which English dictionary is the right source, depending on whether you're in the US or Canada or the UK. So even the English language is a difficult one to say we've got it nailed down, but dictionaries play a role in that, certainly. What else plays a role?
Yeah. Well, and then there's a common vocabulary. So using the analogy again is a dictionary may have words, but the vocabulary would explain how verbs, subjects, predicates, objects nouns would get joined together. So there's a vocabulary that takes place. You can see the analogy of human language is actually very appropriate. Interesting enough, when you start to get the vocabulary together, very quickly you recognize there's common concepts. They're not Sometimes they're nouns, but they aren't necessarily always nouns, but there's common concepts that have a relationship between each other. So you start to get to things like an ontology where concepts have not are identified, but they have relationships between each other. That's where we start to get into really shared meaning, common representation of higher level concepts. And I think that's really where we ought to strive for.
I agree. Now, let's share a couple of examples of vocabularies that are currently governed in the world. And the one that I always think of, because it was so complicated for me to learn, was Health Language 7 or HL7, which was this attempt by the healthcare industry, which is commonly used for the interoperability of systems to have a common vocabulary and relationship between concepts. Now, obviously, I'm not an expert in HL7, but when I hear the word vocabulary, I think of HL7 is a classic example. In my career, we had in the aughts, the financial products markup language or FPML was an attempt to create a vocabulary and structure for financial products you know, that sort of went somewhere. But those are examples of vocabularies. And then you're taking it to the next level, which is an ontology being not just the definition of the terms and the vocabulary that we're restricting the use to, but also the relationship between concepts or entities in what's considered a graph. Like if you look at the background of our podcast, it's a connected map of concepts and relationships.
It's
I
awesome.
think you're onto something because that's where all of the experts around ontologies have been teaching us and talking to us about this problem for decades. And I think ontologies are a first class way of getting into the conversation. So I think you're absolutely
Yeah, well, let's talk a little bit about knowledge graphs and ontology. There's a bunch of different ways that these things can be represented. There's, I think it's correct me if I'm wrong here, I think it's RDF that you can use to map concepts and the relationship between concepts. There's a knowledge graph. I don't know if, John, if you're aware of a standard around knowledge graphs. I'm not, but there's a bunch of different ways you can actually represent these things.
well, yeah, and I stand on the shoulders of all the smart people I've listened to. So my experience is RDF, or the Resource Definition Framework in the Open Web Language, or OWL. RDF and OWL were part of this idea that when we were creating the web, let's have a schema.org. You can go to that website and you can learn all about it as a way we thought when we were inventing the web there, but I wasn't Vint, and I certainly wasn't part of any organizing groups. But when we started thinking about the World Wide Web, that question of semantic understanding of concepts became a first class problem, and RDF and OWL came out of that movement. A lot of people still refer back to schema.org, and it still plays an important role, but nobody would say it worked for understanding everything on the web. But it was a bold attempt. And so when I think about that, I think that's one massive attempt. And there's a bunch of people that I will misquote their name, but the people that have been working on ontologies and knowledge graphs for the last 2 decades have largely not been in the data management team. They've largely been in the information management or the records management, or even in teams that I've not worked with. I think of Ole, our friend, and his work as a librarian inside a pharmaceutical company, where the quality of vocabulary and the quality of meaning of concepts is such an important thing that you really need to draw from library science to understand how to think about knowledge management, right? So what I'm saying is that there's a lot of intersecting forces coming together, bringing different perspectives on this semantic mesh, or this idea that we're talking about. I think it's largely unsolved, and I think it's the richest area which needs focus. Is how I think about it today.
Okay. Now, I want to kind of bring it back to AI, LLMs, and agents, text engineering in particular. So now we've talked about semantics, we've talked about ontologies. How do we apply these to that filling the right information at the right time into the context window? What are your thoughts on that?
Well, so I think this is Act 3. This is where we bring it all together. We've been talking about agents. You've got a great paper that's actually part of your book, but you've written a lot about this. And I think it would be useful for you to share how you're thinking about whether you're going to use the caching analogy, level 1, level 2, or how you think about context and semantics together. I think that's where we are going to see the most progress made in the agentic mesh. But
Yeah.
I
So
would
let
love
me,
you
I'll give
to
you,
frame it. Yeah. Sorry.
yeah, sure. I'll give you kind of my perspectives, and I know you have some opinions on this. First up, just to recap, you got a limited window. Okay, it's growing. Yes, it's growing, but it's not growing as fast as the power and capacity and capability of the LLMs. So the scarce resource today is that context window. And as you deal with any scarce resource, you have to prioritize what's important and what's not. So the first thing is, how do I actually, let me take a step back. Are there some lessons that we can learn from the past that will help us figure out how to utilize this scarce memory resource? And lo and behold, there is. So I did a little bit of research and work back in the day, long time ago, into operating systems. And one of the coolest things I thought was really, really interesting is the ability to use what back in the day was very limited computer memory. And the concept of virtual memory was created. And we had this notion that I had lots of stuff out there, but my computer, my chip, could only use this small amount. And what we ended up doing is we had a very sophisticated set of algorithms to do caching. How do I recognize what I used last and how do I ensure that it stays in memory, and where there's something new, how do I actually bring it in quickly, and then determine if it should actually stay there based off of usage. There's very sophisticated caching algorithms, L1, L2, for example. Now, with context engineering, it is a little bit different. Where a computer would the caching algorithm was really which page was used as frequently and making sure that that was in there. The page was the unit. What we have now with context engineering is the unit, excuse me, the unit is the concept that we actually have to maintain in the context. And if we can understand the request and the concepts that it actually is identifying and using and consuming, and we can actually map that to concepts, whether through a knowledge graph or otherwise, find the right concepts or the right sub concepts and actually pull those into the context window and create L1, L2 caches of concepts. All of a sudden, we will supercharge context engineering because we will have the right information at the right time for the right request, allowing the LLM to do optimal work. That's where things are going, and that's why this whole focus around context engineering, to me anyway, is first off foundational, but is super interesting.
Yeah. Yeah, I agree with you, Eric. I think that is where we're going to see a lot of fascinating developments this year. We've already started to see some at the end of 25. I was in a group where they were just coming back from the Neural Network Conference in San Diego, and they were saying, dude, we just need to join the neural nets at the hidden layers so that we don't even bother to translate it into English so the humans can observe. And maybe that's where we go in the future, right? Maybe the density or the density of information content is better represented as a vector, according to some people in the AI space. Some people think that unless you can represent it in a language that the humans can speak, you're going to do a great disservice to humankind. And so I fall on the side where we need to be able to explain in plain English what the concepts are and how they're used and how they're logged and what concepts and information was used by an agent to make a decision, and it's transparent and traceable. I think the idea of context engineering, semantic engineering, I think all of this has to converge in 26 in ways
Yeah.
that we can
Well,
talk about it even more robustly than we can today.
so here's two words actually that you used that are super enlightening to me is you said context engineering, but right after that you said semantic engineering, which I've not heard before. And maybe that's just because I'm not in San Francisco where the action is, but I've not heard people talk about semantic engineering or concept engineering and being able to summarize a very complex concept based off of the specific facets or views that you may have for that concept and actually distill it into the core piece of the puzzle that can be actually slotted into the context engineering. So I think it's more than context engineering, which leads me to think more about caching L1, L2, but it's actually what you put into the context, which is semantic engineering or concept engineering.
Dude.
Are we onto something, John? Or
Well, no, I think we've gotten to a point in the conversation where we can look backwards, summarize what we just discussed, and I think that's the launching pad for subsequent discussions about this. Because listen, this is all unsolved. This no no no. This wouldn't. This is not a solved problem. And it's going to take a multidisciplinary approach to take people with diverse backgrounds to be able to solve this knowledge engineering, concept engineering. Use whatever term we've used for the last 50 or 60 years. This is the same problem we started with. When we went from one computer to two computers, we immediately had this problem. The language that they're using, as soon as we invented the second computer and they needed to talk to the first one, we saw this problem. So I think this is going to be a big topic for us next year.
there we go. I think that's a wrap, John.
Yes.